Welcome back. We just finished the part 1 of 2.5, multiple angle product to sum formulas, and we did all this beautiful work. But now we're going on to the back side, and we're going to start with half angle formula. So again, on your formula sheet, we have a half angle formula section right here. Oh yeah, look at that. We're going to get into some square roots for this. So again, it's about what is there and how can I rewrite it using my formulas. Okay, that's what the questions we're asking ourselves. So what if I rewrote this as the sine of 210 divided by 2? So now we can use that half angle formula for sine of u divided by 2. So it's a plus or minus. So I'm rewriting this. Again, the u value is just the 210. The u value is the 210 if you look at your formula sheet, not the whole shebang. So I'm going to have my plus or minus the square root of 1 minus u. So u is going to be the 210 divided by 2. So now that I have this cosine 210, I know that I can draw this in this quadrant because this right here is equal to 210. If I want to figure out this angle, I'd subtract 180 so I know my reference angle. So I'm setting up this triangle. Right here across from 30 is 1, square root 3, and 2. This is negative, and my 2. So we're looking at cosine of this. So cosine of 210 is equal to negative square root 3 over 2. So in this equation now, I can replace this plus or minus 1 minus a negative square root 3 over 2, that whole shebang over 2. And now I can simplify that. So on top, I have that plus or minus the square root. Right here, this is like 2 over 2. This becomes a plus plus. So this becomes a 2 plus, the 2 over 2 plus 3 square root 2 over 2. That's a 3. This whole shebang still over 2. So on top, I'm going to have right down here my 2 plus square root 3. That whole thing divided by 2. This whole thing divided by 2. So I'm going to get rid of this division. I'm going to get rid of that division over 1. So I'm going to multiply by the reciprocal. So what I have going on here is the 2 plus square root 3 over 4. Well, this is dandy because now I can take the square root of 4 because you can always move the square roots. If it's around the whole shebang, you can move the square root on top and on bottom. So my final answer here is going to be the square root. Sorry, I don't have that plus or minus. I forgot that plus or minus right there. Plus or minus the square root of 2 plus the square root of 3, that whole thing over 2 because the square root of 4 is 2. And when we're talking about this plus or minus, we go back to this original. When you think of sine of 105, if you were to draw, and I will draw it out for you, if you were to draw this, 105 is right here. So in this case, sine is in my second quadrant, all sad. So that means it's a positive value. So in this case, we were just going to be using the positive answer. You don't need that plus sign, but I'm just showing that we don't have this as a negative answer. It's just a positive one. For example 6, we want all of our possible answers. First thing I notice is this right here, this half angle formula. So, and I noticed that I misprinted this part should not be here, is equal to this. So I'm going to look on this side first. I'm going to work on this side because of this right here. So this on the right-hand side. I'm not going to do anything with that left-hand side as of yet. I'm going to deal with that half angle formula. So just that half angle formula. So this 2 is still on the outside because that's that 2 right there. And that cosine squared, I'm just going to be moving the squared on the outside. So right here, the cosine u over 2 is going to be the plus or minus. We have the square root of 1 plus our cosine u. Our cosine u is going to be the x, so cosine x over 2, this whole thing squared. So again, I'm just simplifying this side of the equation. Now, if I'm going to be squaring this, a positive, negative, it doesn't matter. Something squared is going to give me a positive. So I know that this is going to be positive because of that squared. And that squared takes care of this whole square root. So this becomes 2 times 1 plus cosine x over 2. And now this 2 and this 2, these two cancel each other out, leaving me now with the left-hand side, which we didn't touch anything with that at all. So the 1 plus cosine squared x is equal to the 1 plus cosine x that we just simplified down to. So now whenever we're solving, I'm going to move over that 1, I'm going to move over that cosine, so I'm going to have a cosine squared x minus cosine, because my x's will cancel. I can factor out a cosine x here, leaving with a cosine x minus 1, both of these equal to 0. So now what I am actually solving here is my cosine x equals 0 and my cosine x equals 1, because I would add that 1 over. So again, if you look at your quadrant, cosine is always your x value, so whereas x0 would be here and here, that's where the x value of your unit circle 0, whereas the x value 1 would be right here. So this is asking it for in the parameters of 0 to 2 pi. So these three answers that we have here is x will be equal to 0 right here, because it's not including 2 pi. It's including 0, not including 2 pi. Pi over 2, and 3 pi over 2. So those would be my three final answers. And finally, we have our product to sum. Product to sum. So again, for all of these problems, it's very much just what's the equation. That can be very long, and then write out the formula and try to simplify as far as you possibly can. So in this case, we're going to be using this last one, cosine sine. So our u here, our u value is going to be 5x, and our v here is going to be 4x. So when I use this equation, I have 1/2 times the parenthesis of sine in parentheses our u plus v. So our u plus v is 5x plus 4x. So again, I'm right here, subtract our sine of our u, again, is 5x minus 4x. And if I am going to simplify that, I get the 1/2 sine of 9x minus sine of x. And then I can distribute that 1/2 in. So sine of 9x, 1/2 minus 1/2 sine of x. That right there is my final answer. And last but not least, we have our sum. So our sum to product formula. It's our sum to product. So looking at this first one, we have a sum of these two. So we're going to be using our cosine, which is the last one, or adding our third one on that list. So when you are doing this, so here's my equations that I'm going to be typing into. You should always make sure to write down what your u is and what your v is, so you don't get confused. So if this right here is what I'm working with, now this is going to be equal to 2 cosine of u plus v, so 195 plus 105 divided by 2, times cosine of 195, because that's minus 105, divided by 2. And you need to just start simplifying that as far as you can. Because now this becomes 2 cosine of 150 times cosine of 45. And we have numbers for these. So if you set up your 2, this would be the 150 and the 145. 150 is in between 90 and 45, and 180, so it's going to be right here. So this reference angle right here is going to be 180 minus 150, so this reference angle is 30. So in that right triangle, opposite is 1, we have our square root 3, we have our 2. So cosine of this is a negative, because it went negative. So this would be 2 times a negative square root 3 over 2. And cosine of 45 will be right here, and our 45 is 1 square root 2. So this becomes 1 over square root 2. And if I multiply that across, these two 2's will cancel each other out. So I'm going to have a negative square root 3 over square root 2, which I have to rationalize that, square root 2 over square root 2. So negative square root 6 over 2. That would be my final answer for that problem. Finally, sums. We're going to use our sign. So that top equation. So again, this will be my u and this will be my v. So first thing, I did not use a lot of work. I need more space, but that's okay. We can figure it out. 2, sine. Now for sine, we have our 5x, because that's our u, plus our b, 3x divided by 2. And then we're going to have our cosine of u, so 5x minus 3x divided by 2. And we simplify this. So in this case, it's going to be 2 of sine of 8x divided by 2, which is going to give me 4x, because 5 plus 3 is 8, divided by 2 is 4. And here, 5 minus 3 is 2, divided by 2 is just x. So now, I'm going to focus just on this 2 sine of 4x first. So I set that equal to 0. I would divide by 2, and I would still get this sine of 4x is equal to 0. So if you look at where sine is equal to 0, remember sine value is your y value. Sine is your y. So where is y 0? That's going to be right here and right here. We have our a 0 and our pi. So that would be our 4x is equal to our 0 and our pi, leaving you with x is equal to 0 and pi over 4. Now remember, that's saying every time there's a pi over 4. So that actually cuts it down to our pi over 4 or pi over 2, because it's all in our 1/4 increments. Now if I look at my cosine of our x is equal to 0. Remember, our cosine is our x value. So when our x value is equal to 0, would be these two increments right here. However, that's already included here because we have our pi over 4. Every 1/4 is going to be an answer right here. So that's already actually included in here. We didn't write it out yet, but it's included. So what we need here is my final answer is x equals pi over 4n, because it's going to be every 1/4. So if it's 1 revolution, or if it was 0, it would be at 0. If it's 1, it was pi over 4. If it's 2, it's going to be pi over 2. And each and every time it's going to add a 1/4 to it. So this is where we wouldn't have to add it, because each one of these are going to give me pi over 4. That right there is my final answer. Bing, bada, boom, we are done. Have a wonderful day.